Imagine tracking millions of tiny objects zipping around as they orbit our planet, or making everyday objects like lamps or refrigerators smart enough to talk to each other, or even storing information across a vast web of machines called the cloud. These ideas may all sound like they're coming out of a science fiction movie, but they're technologies that we use every day. Thanks to the hundreds of computer scientists and engineers, we're already living in this sci-fi future. Hi, I'm Taylor from WowSTEM, and today we're talking with Lee Garverick, a computer scientist and product manager who works to develop cutting-edge technologies at a company called Leo Labs. Thanks so much for talking with us today, Lee. So you're a director at a company called Leo Labs, is that right?
Yeah, VP actually, yeah.
Amazing, wow, okay. Could you tell us more about what your company does?
Sure, yeah, Leo Labs is essentially we're building kind of like Google Maps for space, the mapping platform for space. And so we have a couple goals in doing that. One is that a whole bunch of different companies are launching satellites out into space. And we're working to be sure that those satellites don't crash into each other. So we track their routes, the orbits that they have, and then we give them warnings if there's any chance that their satellite could crash into another one. There have been a couple of these incidences in the history of satellite operation. And when it happens, they'll break up into thousands and thousands of little pieces. And then those pieces, when they break up, will orbit Earth for hundreds of years. So any of these collisions create a massive problem. Now, typically they don't actually crash into the Earth. If they deorbit, they burn up before they hit Earth. So it's not a worry for us on land, which is often something people worry about. But on the other hand, it's a worry for the rest of the people operating satellites and launching rockets. And there's the International Space Station that has people on it. And so they're always watching for debris coming at the space station. It's even been in some movies and everything. So that's our main mission in life. We have another thing that we work on, which is some work for the defense sector of the market of watching different satellites and where they are, where are kind of possible threats to these satellites that we're depending on for everything we do on Earth, and making sure that those threats are not doing anything nefarious. So that's a kind of a side operation that we have as well.
So you mentioned these satellites and even the International Space Station. What kind of other things, or what are these satellites that are orbiting around our planet right now?
Oh, there's a whole bunch of different kinds of satellites. For example, probably the biggest of the operator of them all is SpaceX, and they have a bunch of satellites called Starlink. There are several thousand of those, and they're providing internet for people who otherwise couldn't have internet because they don't have carriers nearby. In certain circumstances, they even provide it in wartime scenarios where otherwise people wouldn't have any connections for their internet. But in general, if you look at some of our maps, you'll see it looks almost like a string of pearls going around Earth of all these satellites orbiting Earth. And those are typically SpaceX's. There are others as well. OneWeb, Amazon is building what's called a constellation, a bunch of satellites. And then you have NOAA operating the weather satellites. They're a little higher up, watching the weather down on Earth. So these giant multi-billion-dollar investments in these satellites. There's other satellites that are for GPS, for navigation, that are just critical to everything we do, that are just up there all the time providing this service. There are satellites that are tracking images on Earth for what's happening with climate change. You can see that by measuring what's happening from the satellites. Farming information is tracked by satellites. Shipping information, locations of things, all tracked by satellites. So really important services. And then our company, we don't build the satellites, we help protect them. We're all about the safety of these satellites.
So you mentioned a few different companies. Are most of these satellites coming from like private companies?
There's a real mix. So originally they were all government satellites, like weather and defense and all that. But more recently, in the last 15 years or so, they've become commercialized, and we see a space race coming that's probably as big or bigger than the internet, of the kind of services that can come from satellites over time. There'll be space travel where people can go stay out there. It'll become more and more commonplace. All kinds of other ideas, and a lot of studies coming out of universities too that depend on satellites.
That's really incredible that there's so many different kinds of satellites out there.
Yeah, it's just amazing. I'm actually fairly new to this industry. My background is computer science, and I'm just in love. It's just really cool.
You mentioned GPS in particular. And so I'm guessing that's how my phone can basically get directions. Is that right?
Yeah, that's true. There's other dimensions of GPS that you get from your phone company and from the towers that you're going by as well, and from Wi-Fi. But satellites are a big contributor to having GPS and knowing where you are and getting directions.
So I imagine that these satellites are moving pretty fast, and it sounds like there's a lot of them, as you mentioned. That's quite the challenge to keep track of them, as you are trying to do, as you are doing in Leo Labs. So how do you actually keep track of all these satellites?
So we use radars. We have a technology that we use called ground-based phased array radars, they're radars that sit on the ground, that look kind of like a dish. Ours actually more look like a skateboard half pipe. They're kind of that shape, and they're pointed up, and they're taking pictures of the sky, basically, using radar technology and getting measurements. So anytime that they pick up the measurement of a satellite flying over, they'll send back that data to us. So we track satellites in their orbits, and some of these lower satellites will circle the Earth many times a day, and then the big geosynchronous ones stay where they are and kind of follow the Earth at the pace that the Earth rotates itself. So in either case, our radars get these measurements as they fly over, and then they take that data from wherever the radars are located and send them to the cloud, Amazon cloud. And then that data comes into our system, and then we compute where those satellites will be next. And we make sure that the next radar is looking for the satellite when it flies over there. So we track them as they fly over all the different radars all around the world. So we have a radar in Costa Rica, and one in Texas, and one in the Azores, out an island over in the middle of the Atlantic, in New Zealand. We are just building one now that should be working within a few weeks in Western Australia. So they're all we're trying to basically have these sensors all over the globe, catching all these orbits as they go by. And then updating our data with those. So then the data goes into the system, and then within our system, we calculate where we're going to see the objects next. And then we take those calculations and look at all the orbits of all the objects and figure out which ones might have a collision. And if that's the case, we create this thing called a conjunction data message, and we send those to our customers, and then their computers take those and figure out how to maneuver their satellites so that they avoid those collisions. So there's actually like processing sitting on the SpaceX Starlinks that are taking our messages and deciding then where to redirect the Starlink to avoid anything that might crash into it, and the other satellites as well.
So we talked a little bit about how a lot of private companies are involved in some of these satellites. I was also interested if you know much about if these private companies are also launching rockets into space. Is that related at all to these kind of services?
Definitely. Yeah. So, and we actually have another service that we sell called Launch in Early Orbit, where they have a launch And we often talk to them before the launch, like I was saying, to pick the orbit they want to go for when they launch. Because when they launch, they have this whole plan of they want to get their satellites up to a certain altitude, and then they want to let go of them and send them off. So we'll work with them on the plan. And then once they launch, there's a very vulnerable period where satellites have been lost. They're launched, and it's very important to make communication with them quickly, or else they just fly off and nobody sees them ever again. So we have a service where we are able to put a lot of engineers helping and watch right at that moment of launch. And within the next half an hour to 5 hours, when is that object supposed to fly over one of our radars? And we'll be anxiously watching the measurements from that radar. Did we see it? Is it where it's supposed to be? And then sometimes they'll launch like 100 at once. SpaceX will do this. And we have to help them figure out whose is whose of all these hundreds of satellites. And then we'll send that information to the different satellite operators that are part of the launch. So these launches they call it a ride share. So you can like hitch a ride to launch your satellite with one of the SpaceX launches or some of the other launches. So it's pretty
like an Uber?
Pretty much. Yep.
So looking towards the future, do you see private companies continuing to be heavily involved in space and space exploration in the next few decades?
Yeah, I can't even imagine where this is going to go. It's going to be amazing. This generation of kids gets to see the most amazing progress. I think there's just going to be all kinds of inventions for what can be done in space, what people can do up there, how to keep each other safe up there. Definitely.
So we've talked a lot today about the applications of the technology your company works on, but I imagine all that technology depends on the engineers and computer scientists, as you've mentioned, to develop and run it. Can you talk a little bit more about that side of the work?
Sure. Yeah. So these systems, any of these kind of Internet of Things systems, you could almost imagine like dominoes of all the things that happen to make the system work like you need. So and each piece of it has an expert or a team of experts. So we have our people who can design and build radars, the people who build the processors, the people who are like civil engineers that can actually build these structures that have to be very, very precise to work. And then we have the people who can write the software that can pull these measurements up into the cloud. And then we have all the people that are managing this cloud system where we're sending out millions of conjunction data messages per day. So, and then like figuring out of those, which ones matter and which ones are details that are really never going to be a worry. We have people who are figuring out how to store that data. So every measurement we've ever taken, we have in our storage. So we could do all kinds of analysis of where's the next safe place to launch. If you want to do a new constellation, which orbits are safer? What are the bad neighborhoods that you don't want to launch into? There's too much debris up there. What are the good ones? There's orbital physicists that are figuring out that kind of thing. We have people who are working with Congress on setting policy for what are the rules up there. There really aren't very many yet. So, how do we talk to each other about these things? We have built a communication system between satellite companies where they can share data with each other. Like, oh, I see, they both see that there's going to be a collision. Who's going to maneuver and who's not? And so we built a little system for them to talk to each other as well. So it's like a whole bunch of little pieces that each have an expert.
So you mentioned that your background is in computer science. Is that correct?
That's right. Yeah.
So can you talk a bit about how that plays into your current role, or?
Yeah, sure. So I've spent my whole career in mostly in small businesses doing software products and Internet of Things products, and meaning where there's some kind of hardware with sensors and information coming into some software that people use. So I'm using my computer science every day, thinking about how you design these systems, because a lot of it is a big computer system that happens to be distributed all over the world with these radars. And then our computer system is talking to our customer's computer system. So understanding computers has been very, very helpful. And I loved writing code, but I also love talking to people and kind of sorting out how things should work. So some computer scientists spend their whole career writing code and love that. And I've ended up mixing it up and doing more of this kind of design and communication side along with the computer science. So, but I still use that computer thinking every day.
Yeah, that's really cool to not only hear about how many different jobs there are at Leo Labs, but also hearing different kinds of ways you can use computer science as well.
Yeah. It's kind of its own conversation of that, but it gives you a way of thinking and some kind of basic approaches to solve problems in a systematic way that you can apply all over the place and in all kinds of jobs. So if you're a very social person but still like technology, I think it's still worth giving it a chance, because I have friends who will say, well, I want to work with people, and you can, even if you study computer science as well. Or if you just love building stuff, it's also an awesome thing to learn.
Right. Well, thanks so much for teaching us all about the cool things that you do in your company. I'd love to hear a bit more about how you got to your position today. Where did you grow up?
I grew up in Los Angeles area. So I've been in California my whole life. But my adult life, I went to UC Davis and studied computer science there, and then got a job in Silicon Valley. First writing software. I was writing games actually to start, educational software for kids on personal computers. And then soon after that, decided I wanted to do something where I was working with other people more. So I got a job where I could do what was called technical support. So it was still working with computers, but people would call me with questions and I would help them solve their problems. This is working for Hewlett-Packard a long time ago. So still on personal computers, but how do they use the software we sold to get things done? How can people write new applications? And then from there, I moved into training because that was the next department over, and I thought that looked like a lot of fun. And also trainers got to travel all over the country. And in my younger days, I thought that would be awesome to fly around and do training classes. So I taught classes about how to use HP computers, and got to travel around the world doing that. And then I had small kids and wanted to be able to spend a lot of time not working with the kids. So I worked part-time and had a marketing company all around marketing computer software. And then when the kids got older, I went back again and kind of ended up doing this product management role in a variety of different companies. So getting better and better at this one kind of area called product management. So that then I could use being good at computers and being good at product management to move into this space role. So I've been doing this for about almost 3 years now.
Wow. Well, you're such an inspiration to young scientists and to me. Do you have any advice for young people who are thinking about setting off on a similar path to you?
I guess I would say, think big. There's so much opportunity out there. Remember that sometimes it takes some digging to fall in love with some of these cool things. So you may at first think this isn't for me, but maybe give it a chance first, because when you push through and become a real expert in something, you really appreciate it and can fall in love with it a little later. So it's always a judgment call of like, how long do I stick with this thing that I'm not crazy about? But, maybe think about that and give that a chance. Don't limit yourself. Find other people who are excited about things you're excited about and talk to them. Find mentors that will encourage you. I guess I'd just say, think big, go for it.
That's great advice. Well, thank you so much for talking with us today and teaching us all about the private space sector. Next time I use my phone or computer, I'll definitely be thinking about all the coding going on to make that technology work, and all the low orbit satellites zipping around as well.